Down on the bottom is an I-beam, and that's typical for a little bit longer spans than you would see with the box beam. Also, you're going to see structural products like the inverted T, the ledger beam, other types of products that can be used to create that piece that we just saw all flying in together. So there are a lot of structural products out there as well. Most of the hollow core producers in this area also produce these structural products, and they are the ones doing most of the total precast construction. So that's kind of all of the different products. Does anybody have any questions about those products?
How many units you can put on this prism thing? How many maximum?
Usually they're about 3 stories. Yeah.
For the prisms, do you have to drill a hole for the plumbing, or are they pre-fabbed already?
They can prefab them, but depending on the size of them, if they're more than 4 inches, they'll probably prefab them. If they're smaller than that, they'll probably drill them. Any other questions? I thought I would kind of take you on a little nickel tour of a precasting plant so you can see what it looks like. And we're also going to talk a little bit about pre-stressing at the same time, and why you pre-stress concrete, and how does it actually happen in the plant. First of all, it's important to know that there are several different types of precast, but most of the precasters are all members of the PCI, the Precast Prestressed Concrete Institute. To be a member of PCI, they have to be PCI certified. That means that it's an inspector comes to their plant twice a year, makes an unannounced visit, and spends 2 days auditing the plant for about 175 different items. Things from how do you store your materials, what kinds of records do you keep, what kind of quality control do you do, where are you keeping your cylinders for the concrete that you're testing, is all of your equipment in working order. So all of those things are things that the inspector looks for. That PCI certification is, I used to say like the USDA stamp of approval, but then somebody said, well, yeah, you can't trust the government. So maybe more like the UL Laboratories or the Better Homes and Gardens, seal of approval on your concrete. So it is something to look for. In this part of the country, most of the precasters are PCI certified, so it's not really a problem. Once you know that they're PCI certified, you can look up and see what kinds of products they're certified to do. Bridge producers have to be separately certified because there are certain issues with the loads involved in bridges and the quality of the concrete and the durability standards that you need to meet that bridge producers are specifically interested in. Then you have your standard products, and those are going to be things that are cast in what in our industry we call long line beds. And you're going to see that on Wednesday when you see County Materials. They've changed their name, so I'm stumbling over the name of their company. When you go to County Materials, they're casting all of their bridge products in these long line beds. And that means that they're made out of steel and they're casting multiple pieces at the same time. So they'll all go on the bed at the same time, come off the next morning at the same time. Then you'll also see your specialty pieces. And then when you go up to Lombard Architectural up in Chicago, up in Alsip, you're going to see more specialty pieces, although he does have the capability in that particular plant of doing long line casting. Most of what Lombard is doing are these specialty pieces, so there's more color and texture, and most of the forms are built out of plywood rather than out of steel. They'll probably use those forms 25 to 35 times depending on what they're looking for in that product, and then they'll recycle them. But they'll be specially built for that particular product and more one of a kind, more specialty, and therefore usually a little more expensive. All concrete has to have some kind of reinforcing in it. And all of the, whether it's precast or pre-stressed, you're always going to see some kind of mild reinforcing. And that's going to include your wire mesh, your rebar. Once in a while you'll see fibers being used to reinforce, but not too often. There's some new reinforcement with carbon fiber. where they're using some carbon fiber grids that are being used in the panels, and then they're having wall panels that are just as strong as 6 or 8 inch thick panels, but they're only about 2 inches thick, so that carbon fiber is pretty interesting. Post-tensioning, this is one of those regional anomalies that we were talking about. We don't see a whole lot of post-tensioning in the Midwest. You'll occasionally see it for a bridge or a parking deck, but in general, we don't see a whole lot of it. If you were to see post-tensioning, the precaster would create a sleeve within the product, then it would go out to the job site, the steel would go into that sleeve at the job site, it would get tension there, and then grouted into place. So you would see it that way. Most of the time, if you need extra strength with precast products, what you're going to see is pre-stressing rather than post-tensioning. Pre-stressing takes all of the best qualities of a very durable, high-strength concrete and combines it with high-strength steel. So you've got concrete that's going to be good in compression and tension. So what it's going to create is something with this arch or a camber. We're going to kind of go through the manufacturing process to look at how that happens. This is a typical wall panel plant. And you see the long line beds that I was talking about. They're steel. They're built up a little bit because underneath they do have heating elements. They want to always control the temperature. One of the things that a precaster wants to do is he wants to turn his product over every day. So he's creating new product and getting it out of the plant every day. They do that a couple different ways. One is by controlling the temperature that they have. Another is by using a very low water cement ratio concrete. That means that there's more cement in the concrete that they use, and so the hydration happens faster. You see here they're putting in some wire mesh, and then they're also putting in door bucks and windows, and then there's pieces in between each of the pieces of concrete. So they're casting multiple panels all at the same time on the same bed. This is actually Lombard, where we're going to be. You won't see this particular form because this is from a job about 1.5 years ago, but you can see the difference here in the types of formwork that they have right away. This looks like a skate park. It's got that radius construction on it. It's got a lot of wood. The carpenters really work very hard, and it's all very individual, very unusual pieces. So that's more typical of the architectural type of precasting. Back to the wall panels where we're looking at it in the steel plants. You see here that they've got their wire mesh, and then right here they've got their pre-stressing steel. All the pre-stressing for each of the panels that they're casting in that long line bed has to be the same because it's stressed on either end of the bed. So that's one of the reasons that when you're designing in precast, you want to create a lot of repetition because you want to create panels that use all of the same placement of the reinforcing steel. I brought along a sample of the steel that you're typically going to see in a precast plant. It's called a 7-wire strand. It's a little bit different than what you would normally see with rebar because it actually has the ability to stretch and give a little bit. So if any of you can put about 40,000 psi of pressure on this, you'll actually be able to stretch it. But it functions almost like a steel rubber band. It's called a 7-wire strand because there's one piece of strand going through the middle and then 6 pieces of strand wrapped around it. So, and then if anybody's asleep, you can just poke them with it. So, yeah, you can take off the end of it if you want to see what the strand looks like in there. So they put that strand in place, and then they're going to tension it.